Okay, let's say p is a prime and the positive integer a is its own inverse modulo p if and only if a should be congruent to 1 or congruent to -1 modulo p. And this statement is if and only if, so we have to prove actually two different directions, right? The first one, let's just accept this one. If a is congruent to 1 or -1 modulo p, then a times a becomes 1. And by the definition of inverse, that's exactly saying a is inverse of a. So this direction is trivial. Now let's say a is its own inverse for modulo p. Then by the definition of inverse, we can say a squared is congruent to 1 modulo p. Then by the definition of modulo p congruency, a squared minus 1 must be multiple of p. So p is a divisor of a squared minus p. But a squared minus 1 can be factorized to a minus 1 times a plus 1, and p is still a divisor of this multiplication of two integers. But p is a prime number, so it should be either a divisor of a minus 1 or divisor of a plus 1, which means by the definition a must be congruent to either a is congruent to 1 or congruent to -1 for modulo p. And that's exactly the statement we wanted to prove.